We're going to go back and we're going to look at this exact same problem, but this time we're going to look at the matrix approach, and I want to leave the vector breakdowns that we found in the last video because that's how we can write our Cartesian force vectors. Because remember, the Cartesian force vector is just telling us the x, y, and z components of a force. So if I want to start with my purple force, okay, the force vector, that was for 1. I'm going to have 150 sine 30 I, okay? The y component is heading down, so it's negative minus 150 cosine 30 j plus 0k, because again, we are just in the xy plane. We don't have a z component in forces. So I have the x, I, y, j, 0k, and then I have my unit on the outside, okay? So now let's look at force 2. Force 2 as a Cartesian vector, this time my x component is going to the left, so I have negative 200 cosine 60 I, okay? My y component is going down, minus 200 sine 60 j plus 0k, and our units of force are newtons. When I look at force 3, my x is going to the right, so it's positive. So I have 3/5 times 75 I. My y component is going down, minus 4/5 times 75 j plus 0k, and all of this is units of newtons. If I wanted to sum forces, which we did earlier last week, I could now sum my forces in the x direction. I could show to the right as positive, and I could say 150 sine 30 minus 200 cosine 60 plus 3/5 times 75. I could also sum my forces y, super easy now that I have them in Cartesian vector, up as positive. Negative 150 cosine 30 minus 200 sine 60 minus 4/5 times 75. And if I added those up, I would end up with a resultant vector in the y direction, okay? But this time I want to do the moments. So when I do my moments, I know it's r cross f, position cross force, okay? My position vector goes from the point I'm taking it about, so we're going to draw a big pink bubble over here today, okay, to the vector in question. When I look at force 1, okay, I recognize that force 1 runs in this direction for infinity and infinity and infinity. But I happen to know right here the coordinate of a dot on that vector, and that is at 2, 0, 0. Okay? I also know that I can have a position vector from O to this force vector, which runs along all the way up and down in this direction. I do know this coordinate. This coordinate is 5, 0, 0. So that would be my position vector going to that coordinate. Okay? I know that this force vector runs in this direction, infinity, infinity, infinity. And when I'm using this vector analysis, I don't have to go perpendicular. I just need to go from point A to the point in question, from point A to the point in question. That is my position vector, okay? And I happen to know the coordinate of that point where F3 is touching this angle. If I look at the coordinate, it is at 5, -4, and 0. So my position vector from A to force 1 is, okay, tip minus tail. I'm going to have 2 minus 0. So I have 2i. I have 0 minus 0 and 0 minus 0 plus 0j plus 0k in meters. If I want the position from A to force 2 over here, I can go, there we go, that's my RO force 2, tip minus tail from A to F2. Okay, tip 5 minus 0 is 5I plus 0J plus 0K meters. Now I'm going to do the same thing with 3. Okay, I'm going to go from A to this point because I know the coordinates of this point. Tip minus tail, tip minus tail, tip minus tail. Position. Tip minus tail plus tip, negative 4 minus 0, negative 4J plus 0K meters. And there we have the position vector for each of my vectors given from A to that force vector, and I happen to know one point on that vector line. And I have my Cartesian vectors. So if I were to set this up now, if I'm looking at the moment about A as a Cartesian vector, I have I, J, K, okay, and then I'm going to go here, 2, 0, 0, and then I have 150 sine theta. So I have 75, and then I have 150 cosine, negative 130, 0. And I need to do that for each of these other two. Remember matrix multiplication, down, fish back around. 0 times 0 minus 0 times that. Okay, then I cover up J, 2 times 0 minus 0 times 75. And again, it makes sense those are zeros because our rotation is going about the z-axis. 2 times negative 130 minus 0 times 75. And if we go back and look at our scalar, we end up finding that I have a negative 2 times 75. It matches. So that's how we end up setting it up when we're looking at vector analysis.